In this video, I'm going to try to go over that last example that was discussed in statistics honors class today at the end of class. It was problem number 49 from section 6.1 of the book. I'll read the text of the problem and then we'll look at the directions. DVRs. A research council wants to estimate the mean length of time in minutes the average U.S. adult spends watching TVs using DVRs each day. To determine this estimate, the Research Council takes a random sample of 20 United States adults and obtains the following results. And so 20 numbers are listed, and these represent the minutes that each of those adults spends looking at DVRs each day. And it says, from past studies, the Research Council assumes that sigma, or the standard deviation, is 1.3 minutes, and that the population of times is normally distributed. Okay, so I know I have a sample set or space of 20 numbers. I'm going to enter those numbers into my graphing calculator into a list. I'm going to go stats, edit, and right into list 1, I'll enter the numbers. What the directions ask me to do is to use the given information to construct the 90% and 99% confidence intervals for the population mean. So this is what we're going to be talking about here. My N, the number of items here, is 20. When I use my graphing calculator and I do stats, calculate one variable, statistics, enter, I get that X bar, or the mean, is 15.1 minutes. So that's the average number of minutes that this random sample of 20 adults spends looking at DVRs each day. And sigma, according to my graphing calculator, now my Greek letter symbol, sigma, I believe, is 5.87. But the problem gave me the standard deviation of 1.3. This is when the standard deviation is known. And this is how we begin confidence interval, with a known standard deviation. So we'll look for that information in the problem and use it. So now that I've talked about all that, we need to know, if we're talking about 90% confidence interval, we want to know the area outside of the 90%. So that's when you do a half of 1 minus 0.90. That's a half of 0.10. That's 0.05. So this number 0.05 I use on that table that has remember the z-scores. So I find the 0.05. It's somewhere in the middle of the page, in the appendix at the back there. And I look to the left and up top, and I see that 0.05 corresponds to negative 1 point, it actually will be 645. Now, Mrs. Long called it negative 1.64. That's fine. We're going to use this number in the margin of error formula. So the margin of error is this 1.64. They just take the positive value of that, times 1.3, which is the known standard deviation, divided by the square root of 20, or the square root of n. So I'm just going to write this using an equation editor. I use my calculator, and I get that the margin of error is about 0.477. Now, a lot of people round that to the hundredths place. The book actually rounds this to the tenths place. The margin of error is 0.5. Now that you know your margin of error, this is where your confidence interval comes in. You take the X bar, which is your mean of your set, and so in my case it's 15.1, and I minus my margin of error. That's one end of my interval, and then X bar plus the margin of error. And I get, for an answer, after I do 15.1 minus 0.5, I get 14.6 to 15.6. So this is that 90% confidence interval that the book asked us to do. We could do the same thing with the 99%, but I just wanted to show you the 90%. Then, of course, I'd love to check my audiences in the back of the book and make sure that this is legit. So I'm looking at my numbers, 14.6 and 15.6. And in the back of the book, definitely confirms that this is correct. With 90% confidence, you can say that the population mean length of time is between 14.6 and 15.6 minutes. So I believe that your homework set for tonight is to choose any 5 problems from 6.1 to do. Use this little tutorial as a way to help you do more odd problems. Check your answers in the back of the book. Use your graphing calculator. And I did want to clarify 2 things. This Greek letter is sigma. It's the standard deviation of the entire population, I believe. So double check this with your book or with Mrs. Long tomorrow. Capital S in your calculator is the standard deviation of the sample. And now one of the teachers who teaches statistics gave me a typical problem that could be asked on a test. And the typical problem could be something like this. Given a sample mean of 15.1 and a margin of error is 0.5, determine the correct confidence interval. And so can you see we could get our answer pretty directly of 14.6, comma, is it 15.6? Yes. I hope that helps.